Okay, box with no lid. We want the minimum surface area and the volume is 200 meters cubed. Let's draw a little sample here. I don't know exactly what it's going to look like, but you got 3 dimensions, and it doesn't. And I think the difference between this one and the one we did in Calculus 1 is in Calculus 1 it told me like the length and the width. It gave me the relationship. Like the width length is twice the width, or the length and the width are the same. This one it doesn't. It's pretty wide open. No lid. I want that minimum surface area. Well, yeah, so that means we've got 3 possible variables. And I'm just going to call them X, Y, and Z. You can call them length, width, and height, but X, Y, and Z will make it applicable to what we're talking about here. More obvious, maybe. So I want to minimize the surface area. Well, what is the surface area here? Talking about the, just, you know, putting the 3, all the parts together. Well, it's what, 5 parts together. We got a front and a back, which are XZs. So there's 2 XZs, right? That would be the front would be an XZ, and then the back is an XZ. And I got 2 sides, which is YZ. So I got 2 YZs, but I don't have a top, so there's only one XY, right? With me there? Okay. Well, so to use what we've been talking about, this is a 3 variable system. I want it, what I know to do, stuff to do with, is 2 variables. So I need to get this down to a 2 variable system, formula. 2 variable formula. How do I do that? Well, here's what I've got. I've got the volume locked in to be 200 meters cubed, and the volume I know is XYZ. So XYZ is 200, and if I solve that for Z, then I can take that, plug it in for Z in my surface area equation. That gets it down to a 2 variable system, a 2 variable formula. So it goes here too. So it'll be 2 times X times 200 XY. And then 2Y times that, 200 over XY, plus XY. Cleans up a little bit, I guess. The X's cancel here, so it's 400 over Y. The Y's cancel here, so it's 400 over X. That's about as good as we're going to do. Yeah, so this is this is the difference between the one we did in a previous course, because now that's about the best we can do, get it down to a 2 variable formula. Well, I want to find out the minimum surface area. Well, so the minimum surface area would probably going to occur at the critical points. At a critical point. How do we get a critical point off of the 2 variable formula? Well, you do the partial derivatives, right? So same old. Do the partial derivative. So the partial derivative with respect to X. Yeah, so probably I want to say that's 400 y to the negative 1. I mean, you can use the quotient rule. Easier just to write those as the negative 1 powers there. So the partial of S with respect to X would be negative 400 x to the negative 2 plus y, right? Partial of that with respect to X would just be just y, right? And I think we can get a similar thing for the partial with respect to y. Negative 400 y to the negative 2. This one doesn't have a y in it, so it's 0, just like that one is 0 for the x. Is this okay? Plus the x. Yes? Now what? Well, the critical points are where those equal 0. Or to put it another way, we got negative 400 over x squared plus y equals 0. And then negative 400 over y squared plus x equals 0. Little substitution. Like here, I could say, well, that means x equals 400 over y squared. Probably then, I mean, you could substitute there, the x to be that. One thing I'm seeing. So yeah, I could plug that in there. If I wanted to, I could, make this a little nicer. That would mean y equals 400 over x squared. And so instead of plugging the x there, let's just go ahead and cross multiply. Then I can substitute. You see what I'm saying? You can substitute wherever you want, but I'm just thinking substituting that fraction into that fraction is going to be, you can do it, that's fine, but just make this equation a little easier to substitute. So now let's substitute that in for x. You may not. However, you can figure that out. Okay. That's one possibility. So it'd be y times 400 over y squared squared equals 400. See what I'm saying? That's going to be kind of complicated. So if I put it there, it's even more complicated. Anyway, what we get is y equals it'd be 1600 over y times 1600 over y to the fourth. Well, that's going to bring that down to y cubed. So you got 16 over y cubed equals 400. So again, do the cross multiply. 1600 would equal 400 y cubed, right? Divide off, is that all right? Divide off the 400. That's 4. Y cubed equals 4. Is that right? Y cubed equals 4. So y equals, hey, how about that? Cube root of 4. So the y value is cube root of 4. Probably what I wouldn't have guessed that starting off, but maybe you'll. Cube root of 4. The x, so that would be the y value that minimizes the surface area. The x value, well, x is 400 over y squared. So that'd be 400 over the cube root of 4 squared. Something's not looking right. That's not what I got. Where did I get it? 400. Did y'all see anything I screwed up on? All right, so y equals 400 over x squared. Oh, x is, that's right, isn't it? Then I did that, brought that over, yx squared equals 400. Oh, here's where I messed up. cut, 400 squared is not 1,600. Yeah, there we go. So it's 160,000 divided by 400. What is math? Which is 400. That's what I have. Always helps to have your notes here. Now, better. Cube root of 400. Sorry. Cube root of 400. Now, interesting enough here, one way you can see it is compute that out. Cube root of 400 approximately, 400 over that approximately. These are the same values. It's a cube root of 400, that's a cube root of 400 also. And you can, another way you can see it is you multiply this one by cube root of 400, top and bottom. Because that completes the cube, and so that's just 400 there. Cube root of 400 squared times the cube root of 400, that's just 400, because it's the cube root of 400 cubed. It's just cube root of 400. Like I said, you can see that if you just approximate it too. But so the x is the cube root of 400, the y is the cube root of 400. Turns out though the z is not the cube root of 400. Z is x 200 over xy, so that's the cube root of 400, times the cube root of 400, cube root of 400 squared. Same drill, if I multiply by the cube root of 400 there, again, top and bottom, complete the cube, what do you get there? We get 200 cube root of 400, and then the cube root of 400 cubed is just 400. So this and this reduce back to 1/2, right? So z is 1/2 the cube root of 400. So it's half the size of x and y. So the dimensions that minimize the surface area. It's x equals the cube root of 400, y equals the cube root of 400, and then z equals half the cube root of 400. Or some decimal equivalency there. So, interesting little stuff.